this right here, well, how do you take the derivative of a polynomial, right? X raised to some power. Well, you just use the power rule. And what power rule tells you to do is take this original exponent, drop it down to the side, and then just decrease the number by 1. So say you had x to the third power, then you would just drop the 3 and then subtract 1. So now you have 2 left, right? So that's how you use it, but where does it come from? That's the more interesting question. Now, we already went over product rule, but there is a more general version of product rule for as many factors as you want to. If you take the derivative of, say, instead of 2, maybe we have 4, right? Then what we get is, we take this guy, copy it down, right? Except, we make one change. We take the derivative of the first factor. So now you had a prime, b, c, d. Then do it again. Except now, you want to take the derivative of the second factor, b prime. And then now, drop it again. A, b, c, d. Except now, you want to take the derivative of the third factor, and then so on, right? Now you have a, b, c, d, but the derivative of the fourth factor only. So that's how it works. You just, for each factor, right, you just take its derivative and then copy down the rest of the factors, right? For example, for the a factor, we take its derivative and then just copy down the rest of the factors. Add on, now we're dealing with the b factor, right? You just take its derivative and then tack on the rest of the factors. You have a, c, d. And then same deal with c and d, right? You drop it, take its derivative, and then multiply it on the rest of the guys. So you can kind of see how we're going to use that for this right here. Because what this really is just taking d over dx of a big ass product, right? And there's n of these guys, so I'm going to just write n on top of this dot dot dot. Hopefully that makes some sort of sense. Okay, so we can apply the exact same principle right here. For this first factor right here, we drop it, but remember to take its derivative. And then we copy down the rest of these guys. So there's x times dot dot dot. However, notice that now instead of n of these x's, there's going to be n minus 1. Because we took away 1, right? We took away 1 for the fact that we need to take its derivative. So instead of n here, I'm going to put down n minus 1. Okay? And the same deal with the second one. Okay, now here, so this was the first factor. Now for the second factor, I'm dealing with this x right here. We take that x and take its derivative. Right? And then we just multiply on this x, and then all of the other x's that we haven't touched. And once again, just like last time, because we remove this x for the sake of taking its derivative, we now have n minus 1 of the other x's. So, I have x times x times x, dot dot dot, except instead of n, just like before, I'm going to put down n minus 1. Okay, and then, how many times is this addition going to happen? Well, remember here, we did it once for each term, right? Once for a prime, once for b, once for c, and once for d. So if there's 4 factors, we're going to do it 4 times. If there's n factors, right, we're going to do the addition n times. So I'm going to put a dot 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 here and an n. Okay, so we have that done. But now, we got to simplify some stuff. What's x prime? The derivative of x. That's just 1, right? So if you just remove this and replace it with the 1, it's no different than just putting down whatever we have left in here, right? So I could just put down x times x times x, dot dot dot, and remember this is n minus 1 times. And the same applies for the rest of the factors, because we're always going to be taking the derivative of x, because it's only x's that are multiplying inside of this massive product rule thing. So, just like how we dealt with this one, all the x primes just become 1. And we're going to just be left with this thing, right? X times x times x, n minus 1 times. X times x times x, n minus 1 times. So that exact thing is going to happen to all of the factors, right? Because this is literally what all of the factors are. So all we have to do is repeat this addition n times, right? Because there are still going to be n factors. Now, here's where it gets easy. When you multiply something by itself, say 2 times, that's just x squared, right? If you multiply x by itself 3 times, that's just x cubed, right? X to the 3rd power. So what happens if we're multiplying something by itself n minus 1 times? Well, that's all my eraser's falling apart. Well, that's going to be x to the n minus 1, right? And all these terms are identical. So we're going to just have x to the n minus 1 plus x to the n minus 1. And then so on, still n times, right? N over the dot, dot, dot. Now, say we had y, right? If we added it with y again, right? So we had 2 of these y's adding, this would just be 2y. And then same deal here. If we had 3 y's adding, this would just be 3y. So what if we have n of these guys adding? That would just be n times, well, n times this thing, right? So n times x to the n minus 1. That right there is how you take the derivative of x to the power of n, right?